David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Okay, today's topic is a review of our chapter where we covered expansion and factoring. And those two things are put in the same chapter because they are the opposite operations of each other. So something that you expand in one direction, you can factor in the other direction. Okay, so I'm going to do the review in terms of that. We'll look at all the patterns together. So our first one was distributive property. If I have A times B plus C in parentheses, I just distribute the A on the B and the C, and I get AB plus AC. If I wanted to factor it, I would notice that I had an A in both of these terms, and I could factor it out and end up with A times B plus C. So that's basically the distributive property. So let's do a problem. 6x times x plus 3, I'm just going to distribute. I'm going to get 6x squared plus 18x. Okay? Now I could factor this by going the other way and I'd wind up back here. But instead of that, let's just do a different problem. I put it over here. Now we're going to factor that into this form over here. So if you want, pause the video, see if you can do that. Okay, so I noticed that there is a 9x in both of these terms. So I can factor the 9x out, and that leaves me with 3x in there. And that's a 9x, so we just have 1. So factoring this brings me back here. If I wanted to check my work, I could just do distributive property on this one. I should wind up back there. Okay, now let's do the difference of squares. The basic pattern is a plus b times a minus b. If you FOIL this, you're going to wind up with a squared minus b squared because the middle terms cancel. Okay? Now you can go the other way. If you recognize that you have the difference of squares, you can go all the way back to a plus b times a minus b. So let's do a couple. X plus 3 times x minus 3. I'm noticing that I have this pattern, so I can go straight to x squared minus 9, because that's the a term squared minus the b term squared. Pretty straightforward. Now, going the other way, notice that I have two perfect squares. I have x squared, that's a perfect square, and 64, which is 8 squared. So I can go right back using the pattern and go x minus 8 times x plus 8. And a question I get a lot, does it matter whether the plus or the minus is here or here? The order doesn't matter. Either way is a full credit answer. This one's a little bit more tricky. See if you can do it. You notice that 4 is a perfect square, but 9x maybe isn't super obvious, but let's rewrite this. This is 3x squared minus 4. I put my 3 inside the parens, so that's going to mean this is 3x plus 4 times 3x minus 4. Action. Okay, now let's do the perfect squares. Here's the pattern. I have a plus b squared, so I just have one binomial squared, which is that binomial times itself. Just to know, this is a plus b times a plus b. So a little bit different than the difference of squares. Since both of these are the same, we can just go a plus b squared. Now if you FOIL this, you're going to get a squared plus twice times the a times the b plus b squared. Okay? So this pattern is pretty easy on expansion. Here's one of those, x plus 4 squared. So what I'm going to get is x squared plus 2 times x times 4, so that's 8x plus b squared, which is 16. So that's the expansion of x plus 4 squared. It's a little more difficult going backwards. You have to recognize that you have a perfect square here. So take a look. I've got a square there. That's a perfect square, x squared. And I got a 25. That's also a perfect square because it has a nice square root of 5. So the question to ask yourself is this number twice the square root of that number? And indeed it is. Square root of 25 is 5. 10 is twice 5. So if you've asked those questions and they come up correctly, then all you got to do is go backwards and do x plus 5 squared. The number that goes there is always half of that or the square root of that. Okay? Now let's try this one. A little different. I have a minus in the middle. So check this out. We'll ask the same question. Is that a perfect square? Yep. X squared is a perfect square. Is 9 a perfect square? Yep, it is. So let's check this out. Square root of 9 is 3. 6 is twice 3. So that's going to work. We're just going to have x minus 3 squared there. So that sign is always the same as that sign. Okay, let's do the product sum or FOIL technique. It's called FOIL when you expand. It's called product sum when you go backwards. But it is the same technique, just run two different directions. So FOIL stands for first, outside, inside, last. And it's what you do when you have two different binomials times each other. I do my first, that's x squared. My outside, that's negative x. My inside, that's 2x. And my last, which is negative 2. And then I combine my two terms that are in the middle. So this is going to give me x squared plus x minus 2. So that's the result of foiling this. Now, if you wanted to do a product sum factor, you could do that on this one and you'd end up back here. But instead of that, let's do product sum factors on these two. Okay, so the question you ask yourself, first off, there's no number here, so we don't have to split the middle term, which is what we'll do next. So there's no number in front of this one. Now I want to look for perfect squares. I don't see it. That's not a perfect square, nor is that one. So these ones are not perfect squares. So I've got to find two numbers that multiply to 10 and add to 7. Okay? And those numbers are 2 and 5. 2 times 5 equals 10, and 2 plus 5 equals 7. So 2 and 5 are my two factors over here, and it's pretty simple. This is a one-stepper. X plus 2 times x plus 5. Now if you wanted to check this, you could FOIL this one, and it should take you right back to that one. Okay? Last one. Product sum. Two numbers that multiply to 2 that add to negative 3. And those numbers are negative 1 and negative 2. Because multiplied, they make a positive 2. Added, they make a negative 3. So this is just going to be x minus 2 times x minus 1. And that's that pattern. Okay, now let's do some splitting the middle term. And this one doesn't have an expansion analog. It's just a factoring technique. And it's helpful for when you've got a number in front of the x squared term. Okay? You could use it on the simpler problems, but it's way more steps. You should know how to product sum factor that, difference of squares, those kinds of things. So the first step, whenever you have a number in front of your x squared, is to first see if you can factor it out of the other terms, because that will make things a lot easier. Unfortunately, we can't do that in here because there's no 3 in negative 7. There is a 3 in negative 6, but not in negative 7. So we're splitting the middle term. So the trick here is you multiply your a by your c. AC, so 3 times negative 6 equals negative 18. Now we need two factors of negative 18 that add up to negative 7. And those factors are minus 9 times 2. That's negative 7, and minus 9 plus 2 is negative 7. Minus 9 times 2 is negative 18. So negative 9 and positive 2 are the two numbers that we're going to use to split the middle term. So we do just that. 3x squared minus 9x plus 2x minus 6. So we haven't changed our expression. I could recombine these and wind up back at 7x, at negative 7x. So that's good. But what we do now is we have two pairs that we can factor. And also, it doesn't matter which way you go. You could put the plus 2x here and the minus 9x there. The steps will be a little bit different along the way, but the answer should be the same. Okay, let's do this. Common factor in these two, greatest common factor. 3x times x minus 3. If I distributive property that, I'm going to wind up right back there. Greatest common factor here is just 2. X minus 3 is what's left. So we know we did this right because both of these are the same. If they're not, then either it's not splittable by the middle term, or you've got a little boo-boo along the way. So the last step is just to take these two guys here and do 3x plus 2 times x minus 3, and we're done. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.